Hello everyone, welcome to my channel. Now in this video we are going to discuss the topic of relative motion in two dimensions. Basically we'll be discussing the fundamentals in this concept. So if you have any doubt with regard to this topic, you can have a look on this video. Now suppose you have a Cartesian coordinate system wherein this is origin, this is x-axis, this is y-axis and this is z-axis. Okay, and suppose object A is at this particular position and object B is at this particular position. Okay, now how do we define the position of A and B? By drawing position vector RA and RB. Okay, now see, these vectors I have drawn from origin O. That is, position of A and B is defined with respect to origin O. Okay, so this arrow is drawn from O to A, from O to B. So RA is drawn from O to A, RB is drawn from O to B. Okay, so now if I have to find, see, position of A with respect to O means arrow is drawn from O to A. So similarly, if you have to find the position of B with respect to A, okay, position of B with respect to A, then you have to draw the arrow from A to B. Okay, so this is RBA. So this is position of B with respect to A. Okay, so this is RBA is position of B with respect to A. Okay, because vector is drawn from A to B. Okay, now this is a triangle. Now in this triangle you can see that RA and RBA, they have this clockwise sense of rotation and RB has anti-clockwise sense of rotation. So if you apply triangle of vector addition, this side will be the resultant of these two sides. So we have RB is equal to RA plus RBA. So this gives RBA equal to, this goes to this side, so this is RB minus RA. So this is how we represent position of B with respect to A. Okay, so this is the expression for position of B with respect to A. It is position of B minus position of A. Okay, now suppose A and B, they start moving. Okay, now if A and B starts moving, then RA and RB will change, and if RA and RB changes, this quantity RBA will also change. So let us find the measurement of that relative change. Now relative change in position will be given by velocity. So if we differentiate this quantity, so this is d by dt of RBA is equal to d by dt of RB minus d by dt of RA. Okay, so this is velocity of B with respect to A is equal to d by dt of RB will be VB. So velocity of B minus velocity of A. Okay, so this is how we write relative velocity of B with respect to A, or velocity of B with respect to A. Okay, now let us see what are the implications of this expression. So we have expression for relative velocity as relative velocity of B with respect to A as VB minus VA. So relative velocity of B with respect to A is equal to velocity of B minus velocity of A. Now similarly, position of B with respect to A, it is position of B minus position of A. Now for acceleration we can write this as acceleration of B with respect to A as acceleration of B minus acceleration of A. Okay, so now suppose we have two particles A and B which are moving with regard to the same frame of reference. Okay, so velocity of A, it is given as UA, this is final velocity of A, UA initial velocity of A plus acceleration of A into t. So this is for particle A. Okay, and similarly for particle B we have VB is equal to UB plus AB into T. Okay, now if we subtract these two equations, okay, what do we get? VB minus VA is equal to UB minus UA plus AB minus AA into T. Okay, so what is this? VB minus VA is relative velocity of B with respect to A. So VBA is equal to UBA plus ABA into T. So this is how we can modify the equation of motions, the three equations of motion, in terms of relative motion. Similarly, this is the first equation of motion. This is called the velocity time relation. Similarly, the relation S equal to ut plus half at square can be modified as for relative displacement of B with respect to A. So for that we can write this as SBA is equal to UBA into T plus half ABA into T square. Okay, and last equation VBA square minus UBA square is equal to twice ABA into SBA. Okay, now everywhere, see, in this case also T, here also T. I have not written the subscript for T because T does not depend on the frame of reference. Okay, it will be same with regard to A or with regard to B. Okay, so these are the equations of relative velocity, relative displacement, relative acceleration, and this is how we can frame the equations for the three equations of motion with regard to relative motion. Okay, now let us apply this concept to a situation that is man in rain. Man in rain. Okay, now suppose rain is falling in a vertically downward direction. This is velocity of rain, and a man, he is walking in this direction with velocity Vm, and he is having an umbrella, and we have to find in what angle he should hold the umbrella so that he is able to protect himself from getting wet. Okay, now you might have seen that suppose it is raining in a vertical downward direction, but if you are going in a cycle with the umbrella in your hand, then you need to hold the umbrella in the forward direction. Okay, because if you are going in a cycle, you will be experiencing as if the rain is falling from the forward direction. So that thing we are going to observe here mathematically. Okay, see, this is the direction of velocity of man, and this is the direction of the velocity of rain. Okay, this is with reference to the ground frame, with reference to a frame of reference which is at rest. Okay, so ground frame is the frame which is at rest. Okay, so now the rain is falling downward. This is the direction of velocity of rain. Rain is falling downward, man is walking horizontally. So this is the velocity of man. Okay, so see, if I find the resultant of these two vectors, this vector, it will give me Vr plus Vm. Okay, Vr plus Vm, which is of no significance, because just now we have seen when we are finding relative velocity between two quantities, basically we are subtracting those two quantities. We are taking the vector difference of the two quantities. Okay, so this is Vr plus Vm means adding those quantities. Okay, so now you may have the confusion like whether we have to find Vr minus Vm or Vm minus Vr. Okay, see, Vr minus Vm is Vrm, that is velocity of rain with respect to man, and Vm minus Vr is equal to Vmr. Okay, so that is velocity of man with respect to rain. Okay, now velocity of man with respect to rain means we need to protect the rain from man. So that is in what velocity of man with respect to rain. So in what direction the rain will receive man, but that is not a problem. we need not protect rain from man. Our goal is to protect the man from rain. So we need to find the velocity of rain with respect to man. When the man is walking, in what direction he will receive the rain. Okay, because when he is moving, he will be getting the rain in a relative frame of reference. Okay, so that is the reason we need to find VRM and not VMR. Okay, so we need to find, so now this is clear to us that we need to find the value of VRM. Okay, that is VR minus VM. So this is VM. Okay, so what will be the direction of minus VM? Minus VM will be in this direction. So this is minus VM. Okay, now this is VR, this is minus VM. So resultant of these two quantities will be in this direction. So basically we are adding. Okay, in subtraction also we are adding by taking the opposite direction. This is VM, so this is minus VM, and now this is VR plus minus VM. So that is nothing but VR minus VM. So that is equal to VRM. So this vector represents VRM. So that is velocity of rain with respect to man. So that means this is the direction in which the man need to hold the umbrella. Okay. So now this angle of the umbrella, it is always measured with respect to the vertical. So this is the vertical position. So with respect to vertical, the angle through which the umbrella is rotated is theta. This is the vertical direction. So this angle is theta. Okay, so that means this angle is theta. Okay, now if this angle is theta, this is vertically opposite angle, so this angle will also be theta. So our goal is to find the value of this theta. So tan theta will be equal to this side, length of this side divided by length of this side. So length of this side is equal to this length of this side. So that is, so I can shift this vector parallelly over here. So this is VM and this is VR. So tan theta equal to VM by VR, or theta is equal to tan inverse VM by VR. Now here you may have a doubt that this is VM, this is minus VM. So while calculating tan theta, why I am taking VM without any sign? Because this is angle is the ratio of sides. Okay, ratio of length of side. So length means magnitude. So we also only need to take the magnitude. Okay, so this is tan theta equal to VM by VR. So this is how you can calculate the angle at which the person need to hold the umbrella. This is the angle. And how about the magnitude of the velocity? Magnitude of the velocity will be simply VRM is equal to square root of VR square plus VM square. So this is how you can calculate the magnitude of the velocity, and this is the direction of velocity. Okay, so this is one example of motion in 2 dimension. So I hope this concept is clear to you.